Today we're going to be looking at congruent figures versus similar figures. Congruent is a word that we're very familiar with. We've focused on that a lot this year. Similar is something you've probably heard of, we just haven't talked about as much. So on the left-hand side, we're looking at two congruent triangles. We have this statement, triangle ABC is congruent to triangle A prime, B prime, C prime. So what does two figures being congruent means? It means that all corresponding sides and corresponding angles are the same exact measure. They are congruent. So if I take every single side, segment AB is congruent to segment A prime, B prime. They have the same exact length. I know they are congruent because they are represented with one tick mark. Segment BC is congruent to segment B prime, C prime. Once again, I know this because BC has two tick marks and B prime, C prime has two tick marks, which means they're of congruent measure. Segment AC is congruent to segment A prime, C prime. Once again, I know this because they have three tick marks indicating that their segments are congruent. So each corresponding side matches up with one another. Each corresponding length is equal. The same is true with angles. Angle A is congruent to angle A prime. This is represented through one of the half circles. Angle B is congruent to angle B prime. I know this because they both have two arcs. Angle C is congruent to angle C prime. I know this because they have three arcs. Similar figures are not exactly the same. They are the same shape, they're just different sizes. So we represent that by saying quadrilateral WXYZ is similar, just a tilde, no equal sign underneath, to quadrilateral W prime, X prime, Y prime, Z prime. So what does it mean to be similar? Similar figures only have corresponding angles that are congruent. The corresponding sides are proportional. So the only statements that we can make of congruency deal with their angles. So angle W is congruent to angle W prime, one arc. Angle X is congruent to angle X prime because of the two arcs. Angle Y is congruent to angle Y prime because of the three arcs. And angle Z is congruent to angle Z prime because they each have four arcs. So how does this relate to all the transformations that we've been working with? So up in the top right-hand corner, coordinate number 1, this is an example of a translation or a slide. So triangle ABC simply slid to the right and up. It had no effect on this triangle's size. It didn't change. So a translation, which is a rigid motion, shows congruency. Triangle ABC is congruent to triangle A prime, B prime, C prime. Corresponding sides are congruent. Corresponding angles are also congruent. Example 2 is of a rotation. So triangle ABC rotated 90 degrees clockwise. The size of the triangle did not change. It remained in shape. Therefore, a rotation also shows congruency, and we can say triangle ABC is congruent to triangle A prime, B prime, C prime. Example number 3 is a reflection. We are reflecting about the y-axis. Once again, the triangle's figure did not change, it just moved. This is another example of congruency. Triangle ABC is congruent to triangle A prime, B prime, C prime. The last example is our only example of a non-rigid transformation, and that's dilations. Triangle ABC was dilated by a scale factor that was bigger than 1 since it's an enlargement. However, the triangles are not congruent. They are similar because the side lengths are proportionally bigger. Therefore, triangle ABC is similar to triangle A prime, B prime, C prime. So our examples are going to be called transformation compositions, which means we're going to be doing multiple transformations to the same exact figure. So we are looking at triangle ABC, and I already graphed it with the coordinates 3, 3, 6, 3, 6, 6. The first rigid transformation is to translate our triangle 9 units to the left and 2 units up. So I'm going to take each of my coordinates and go 9 to the left, 1, 2, 3, 4, 5, 6, 7, 8, 9, 2 units up, and I'm going to make sure that I label it as A prime. I'm going to continue with B, 1, 2, 3, 4, 5, 6, 7, 8, 9 to the left, 1, 2 up to get B prime. C's 1, 2, 3, 4, 5, 6, 7, 8, 9 to the left, and 2 up to get C prime. I'm also going to make sure that I connect the dots to create the figure. Triangle ABC is congruent to triangle A prime, B prime, C prime. It's just in a different location. Next, we're going to take triangle A prime, B prime, C prime and reflect it over the y equals x line of reflection. So I'm going to draw on here our line y equals x. Now, I showed some of you in class this trick, but I think this makes counting or reflecting over a diagonal a little bit easier. So we're going to count how many units down to our line of reflection, and we're going to move that many units to the right to reflect over the y equals x. So with B prime, I'm going down 1, 2, 3, 4, 5, 6, 7, 8 units. So I go 8 units to the right. 1, 2, 3, 4, 5, 6, 7, 8. This time it is labeled as B double prime because it's a second transformation. C prime down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units to the right. And then A prime is down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to get A double prime. Connect my dots or my coordinates to get triangle A double prime, B double prime, C double prime. Again, all of these triangles are congruent to one another. Triangle ABC is congruent to triangle A prime, B prime, C prime, which is All we're doing is simply shifting and moving the triangle around. It does not affect its size. The last thing we're going to do is rotate 270 degrees about the origin. When it doesn't state how many degrees you are rotating, it's always counterclockwise. So I look at my rotation rules, and my rotation rules for counterclockwise is y negative x. I think that it is easiest to write down our coordinates and then flip them. So A double prime has the coordinates of 5, negative 6. I'm going to flip-flop my x and y and negate the x. So that changes into negative 6, negative 5. This gets labeled A triple prime. B double prime is 5, negative 3. Once again, I have to change that to y negative x, and it becomes negative 3, negative 5. B triple prime. And my last coordinate, C double prime, is 8, negative 3. I want to rewrite that as y negative x, so that becomes negative 3, negative 8. So I went through all 3 of the rigid transformations, and all 4 of these triangles are congruent to one another. The last transformation composition that we do is going to be a combination of both rigid and non-rigid motions. So we're going to start off with square ABCD, and it is already graphed for you. The first thing we're going to do is we're going to reflect over the line x equals 2. So x equals a value is a vertical line, so I'm going to draw a vertical line to get my line of reflection. And then I'm going to count how many units to that line of reflection and continue in the opposite direction. So I'm going to start with A. A is 1, 2, 3, 4, 5, 6, 7, 8. So I continue 1, 2, 3, 4, 5, 6, 7, 8. And that will be labeled A prime. B is also 8 units away, so I'll continue 8 in the opposite direction to get B prime. C is 1, 2, 3, 4 units away, 4 in the opposite direction. D is also 4 units away, so I go 4 in the opposite direction. I connect my coordinates. Since this is a rigid transformation, the shape of the square did not change. So square ABCD is congruent to square A prime, B prime, C prime, D prime. Last thing we're going to do is dilate with a scale factor of a half. I find it easiest to write down the coordinates. So A prime is 10, 2. B prime is 10, 6. C prime is 6, 6. And D prime is 6, 2. Therefore, all I need to do is multiply all my coordinates by half. So A double prime becomes 5, 1, because that's half of 10 and 2. B double prime becomes 5, 3. C double prime becomes 3, 3. And D double prime becomes 3, 1. So I plot my points. 5, 1. 5, 3. 3, 3, and 3, 1. And I have a similar triangle because it is a smaller version. Therefore, it is similar, not congruent, to square A double prime, B double prime, C double prime, D double prime.